Okay, so this Thales competition has tasked us with creating an Arduino powered project. We pretty much have free scope, but it has to be something involving one of the areas that Thales are involved with. Our application, we were thinking along a more military based, not necessarily to do with conflict, but more navigation for time critical situations, such as a soldier who is engaged with an enemy, and let's say that they need to know where they need to get to. They have a new destination that might be given out by a commanding officer, and instead of having to stop and look at a map or a GPS device, that they would have some other device that they wouldn't have to stop and look at, but they would still know how to get to their destination and where that was. And that's why we have created the Wayfinder belt.
It's basically a compass that you wear that knows where you're going and vibrates in the direction you want to be heading.
Some of our inspiration was actually the fact that wearable tech is actually becoming a bit of a trend at the moment. The likes of Samsung releasing several smartwatches recently, and the whole idea of technology becoming smaller to a point that you almost don't realise it's there. And that's our kind of vision that we had for what if this was to become a project, that you could have a belt that was seemingly just an ordinary belt but had this additional functionality. Dan is wearing our Wayfinder belt, which is going to be used to tell him where to go. If you turn around, Dan, so you can't see what we're doing. So using this app, we can now sort of communicate with the belt, if you like, and we can tell it where we want to go. This map here, this is this field that we are in, and just by pressing somewhere, so I have set the destination there when I press this, which is just over that way. Dan should now be able to make his way to where I've pressed.
Getting something.
Right, that's good. Right, so Dan now thinks he's here. That's where we set the destination to. And that's about where we are. If you look round, we're about halfway between the field, just next to the main road. Fantastic.
That worked.
I'm going to show now a little bit about how the belt actually works. The output is a form of haptic feedback provided by these vibrating motors that are spaced along the belt. The motors that vibrate are the direction you want to be heading in. This is how we achieve the feedback to the soldier or the user of the belt. It's how we give that person the instruction to move in a particular direction. Obviously, if a particular motor vibrates, the user doesn't have to look at it, have to stop, they just know that is the direction that they need to be heading. The brains of the operation is stored in a unit here. We think that in a real life application this could be shrunk down much smaller. Obviously this is just a proof of concept more than anything.
Here we have the Arduino itself, which was given to us. We have a GPS, Bluetooth device, accelerometer and a magnetometer, all connected onto a proto shield on top of the Arduino itself. We have a Bluetooth device which lets us connect to either a host device, either be a smartwatch or a phone, and send coordinates to the device. We have the GPS which lets us calculate the bearing and tell us where the Arduino is itself. We have the magnetometer, which uses an algorithm to detect where north is, and we also have an accelerometer which will allow us to, with the help of the magnetometer, use the Arduino in any orientation.
So on the screen here we're outputting some information for debugging purposes, and it's useful to see some of the things that the Arduino sees as far as values for the different modules we've got with the Arduino. On the leftmost side here we have values for the accelerometer, X, Y and Z going along there. and you can see if I move this in the x-axis, these are resting at around 30. If I move this up, you go there, you see the numbers change there, and in the y-axis you see the y column change there as well. This second row of numbers here, these are to do with the GPS. Unfortunately we're inside at the moment, so those aren't going to give any real values, but if we were outside having satellite coordinates, those would give us latitude and longitude there.
Here we have the magnetometer values in X, Y and Z as well, correspondingly. If I move these around, you can see that the X value here changes depending on which way is north. We have an algorithm in the code which will calculate which direction is north and give us a bearing for it. And output it to these values here, which are the outputs to the vibrators themselves. If you see here, that's when I rotate this, the numbers should shift along here, which corresponds to the belt rotating as well and vibrating in different angles.
Right. Go. That's going in the film.
No, it's the very end. Right.
Yeah, vote for us.